Hello everyone. In the previous video, we started converting our shape2D class into something called a base class in which other classes will inherit from. So now we're going to start the process of converting myRectangle.h and rectangle.cpp into simpler objects and compare how, when using object-oriented programming, we can let shape2D do some of the heavy lifting for us. So let's start with myRectangle.h. So here it is with all the methods, getters, setters, constructors, and such created as an independent class. So what we'll do now is that we will actually get rid of all this and get rid of all this now. And we will start by including pieces of the shape2D class into this class. So we first start by including the declarations of my shape 2D. Here now, this lets us inherit from this class formally, and in order to declare a class that inherits from another class, otherwise known as a derived class, which we will note here, that rectangle is a derived class which inherits from shape 2D. And with this relationship, the class that inherits from another, the one that is inheriting, is called the derived class, and the class that another class inherits from is called the base class. So shape 2D is the base class and rectangle is the derived class. So how do we tell our compiler that this class, the rectangle class, is deriving from the shape2D class? Well, we'll do something like this. I'll put a colon and say public shape2D. So why am I putting public here and not something like protected or private? Well, with public, what happens is that when we inherit data from shape2D is that we will inherit protected data, and it will remain protected for the rectangle class, and we will inherit public data from shape2D, which will remain public in the rectangle class. If we did something like protected, a protected inheritance, meaning that I replace this with protected, everything that is protected remains protected, and everything that is public becomes protective. And I don't want that. I want everything that's already public in shape2D to remain public. So I don't want to use the protected inheritance. And if I do the private inheritance, well, everything that's public in shape2D becomes private in class rectangle. Since the protected and the private options of inheritance isn't something that I want, I'm going to stay with public. And most of the time, you will see this as the normal convention of inheriting. You will usually see that when you inherit from a class, it's usually through public inheritance. And that's why in shape2D, I have what's supposed to be the private data as public, as protected, not public. Which is why I have what's supposed to be the private data in shape2D converted to protected. So that way when I do a public inheritance, this data stays protected. Something to note and something to say is that if any attributes are private or any methods are private, they always remain private, even if you do any sort of inheritance. If the base class has any private data, any derived class cannot access it. The only exception is that in the class that they are provided getters and setters. But other than that, any derived class cannot access private data directly from a base class. With that being said, now let's go about creating the private data. In the private data, when we implemented the class independently, we had 4 attributes: length, width, area, and perimeter. In this case, since shape2D already has the length and width attributes, we are only going to fill in what we want to add, which is going to be the area and the perimeter. And these will be private because we do not expect any other class to inherit from rectangle in this case. Now, if we were under the case that maybe something else might inherit from rectangle, we might want to change this private data into protected data. But in this example, we are going to say that rectangle is going to be the end of the line in terms of inheritance, so we will leave it private. However, in the future, if you wanted to make a class that would inherit from rectangle, I would advise that you turn this private data into protected data. So what's different now? Well, with shape 2D there, we are given everything that is shape 2D. So we are given its constructors, its destructors, its setters and getters, miscellaneous methods, and we have the overloaded operators. Now, something to clarify is that these overloaded operators work within the shape 2D data that's inside of rectangle. So this does not update rectangle in any way. We have to define our own. Well, actually, we can't define our own because there's no virtual in front of it. So while we do inherit these operators, it is not an inherited method or operator overload that we can edit. The only methods that we can overload are the ones that have virtual in front of it. So we have access to the getters and the setters, but we cannot modify and make an updated version that only appeals to the rectangle class. And that is because they don't have virtual in front of it. We do have the opportunity to override and create new versions of these methods because they have virtual in front of them. So with that being said, we really only have to account for our three constructors, right, which will be the unparameterized default constructor, the parameterized default constructor, and last but not least, the copy constructor. Again, I am adhering to best practices of using a const and a reference for the argument. And here we are declaring. And since I'm inheriting the destructor from shape 2D, I'm actually going to omit it here in the class declaration. So now, what's new? Well, what do we have to define here now? Well, something to note is that we actually inherit the getters and setters for length and width. So what's left to declare? Well, there's a get area, right, that's left over from when we created the class independently, and we also have a get perimeter that we created independently. This still doesn't change. We also have to overload the equals operator, and we'll do that by returning a reference to a rectangle, and we'll have operator equals. And for the right hand side of what's on the right hand side of equating one rectangle to another, we'll have a const rectangle rect. Again, these are all declarations. We are not going to be implementing anything in this header file. We are just declaring. Right, and the reason I have to redefine all these operators is because in the parent class, I inherit the shape 2D version of what to do with these operators, but because this is a rectangle class and I can add new attributes, it is good for me to overload these operators to my own accord. And here we are going to overload the double angle brackets for the less than for printing as we would by using cout, right? So here we finish our header file. Now, for the rest of this video, we are going to update the three constructors in the rectangle CPP file, and in the next one, we'll cover the rest of the methods. So why don't we get rid of all this for right now? We'll start from scratch, and we'll start by implementing this. One thing to note is that I don't have to change my header includings for this, because when I include my rectangle.h, actually include my shape2d.h. So these are the only operators that we need to define, which is actually pretty great. This is a pretty cut version of what we had before when my rectangle was an independent class. I have about 4 less methods that I have to deal with. I have 2 less attributes that I have to deal with, and it's quite nice. So let's go about implementing these 3 constructors. So when I'm implementing this, one thing to remember is that in the base class, I need to do some implementation of that going on. So what I need to do is I need to call the constructor for my parent class, which is shape2d, because I can let the parent class initialization do some of the heavy lifting, so that way I don't have to initialize the length and the width attributes of the class. So the way to do that is to call the shape2d classes constructor right here. We have a semicolon shape2d, and then here what I can do is I can say area is equal to my area method, and perimeter is equal to my perimeter method. Right? When this was an independent class, all I had to do was deal with the 4 attributes, but here, because shape2d can already take care of the length and width attributes, I call that constructor to deal with those attributes. So now let's see what goes on when we have our parameterized default constructor. This will have a double length as an input and a double width as an input. And let's make sure that this is consistent with our header file. Double length, double width. This is good. So we have that here. And what I'm actually going to do is something similar to what I did with the unparameterized constructor, is that I'm going to call the parameterized default constructor in shape2d to have length and width. So I'm able to have the shape2d's parameterized default constructor also help out with the creation of the rectangle class, because shape2d already has it. So when I inherit that, I can just call it. And this will allow me to pass off some of the responsibility of dealing with some data that already exists with shape2d and let the class itself deal with it. All I have to do is something similar to that I did with the unparameterized default constructor, and I can keep that the same. Lastly, why don't we take a look at the copy constructor. So we'll have our const rectangle. We'll have a reference to our rectangle here. And this will actually be a little bit similar. So something that I skipped out on is that I didn't have the call to the parent class, but actually can do the same. So we'll have shape2d, and we'll have the argument rec.get length. We'll have rectangle.get width. And we can do the same process that we have done with these two right here. So I actually call the parameterized default constructor here, and what I'll do here is I can just copy this. So this is pretty nice because I can let the parent class do a lot of the heavy lifting for me because it already exists. The infrastructure for dealing with length and width already exists within shape2d. So I'm letting that happen. In the next video, we'll be finishing up the rest of the methods, which shouldn't take too long, given that I have 4 less methods to implement than I did when I created Rectangle as an independent class. Thank you.